Join discord.gg/flat earth and enter a VC check-in room, and someone will come along to VC verify you to get involved with the conversation about our Earth.
Stickiermoss Part 2.
Enemy spotted.
It's only because gravity and all to provide a scientific experiment for it. Sorry, guys. Hello, Sticky. How you doing?
Good evening, everybody. How's everyone's day? It's a weekend, right? Happy Friday.
Dude, I got my air conditioner fixed finally, so I'm happy.
That is great news. Yeah, that's something to be thankful for. Someone wanted to disprove gravity.
Hold on. You've got to prove it first with a scientific experiment. So prove it.
Oh yeah, if you want to know why I think the Earth is round, or rather, no, is because I work with satellite systems.
That's awesome.
I've actually talked to Elijah about this.
Sorry. Sticky.
He's Sticky. In there. What's up, dude?
You said gravity. You said gravity, and then you went off talking about bloody satellite.
Yeah, dude, I'm not a physicist.
Yeah. Listen, dude, please, I got a headache. It's late. Just give me a chance. I'll be quiet and I'll be respectful. All right. You said gravity. We've got to disprove it. You kind of missed the point. I said you've got to prove it first before we can.
Right. We don't have to talk about it.
Well, you don't have to talk about it. You brought it up, so I'm going to hold you to it. Have you got a scientific experiment that proves it?
Right. Before so when you guys were talking about the water, I brought up the gravity because that's what keeps it level, right? So I can't really speak on gravity.
That's fine. You brought it up in the live stream voice text. I asked you for an experiment. Not that's what keeps
the Cavendish.
Oh, okay. So can you give me the independent and dependent variable within the Cavendish experiment, please?
Not really. I mean, I've said it before because I read it briefly after being asked this. I was like, no, I don't know. And then I looked it up. It's like you got a probe, right? And a little needle essentially coming down between two different size objects, and then they find the variance between the movements. And then they were able to infer that, yes, mass attracts mass. Now, that's my Spark Note version. But they were also able to determine the size of the Earth, and that's how we get our distancing. That's how we know how far away the moon is. That's how we know.
Sorry, just very quickly, could I jump in quickly since you're jumping off the back of something that I was speaking about? So you said gravity is the reason that water is level. Is that right?
I said that, yeah.
Okay, so could you look in the live stream voice text channel?
What am I looking for?
So the definition of level that I just posted, could you read that top one, what it said?
Yeah, flat. That's what I thought.
Right. So gravity makes the water flat, is what you're saying?
Yeah.
Okay. Welcome to Flat Earth.
No, I like it. That's a great one. I like it.
Yeah.
Yeah. No, flat is,
Level.
Oh no, what's the word I'm looking for? So we're
Flat is a surface condition. That's the word you're looking for.
correct. So water on a ball, like condensation, right? It's stuck there with the force, right? Level water, I get it. Celestial object, very big, right? And then you got these little riddles here. I get it. It's
not much to
fun.
get. You just agreed that the water's flat. I mean, you can think the water's flat for whatever reason. Gravity, magical elves. I don't really care why you think the water's flat, but you agree that it's flat. That's fine.
I agree that water, is free forming.
No, you said
and
Well,
buoyancy,
you said
density,
level, which is flat.
density, and gravity are all a thing. But like I said, I can't really speak on that. So your gotchas are going to get me.
Welcome to flat Earth. See you later.
You know? Well, I mean, I can't be
Not really a
welcome
gotcha.
because
It's just,
I'm not
level is
in
what
it.
it is.
You
Water
know?
is level. Level has a definition. I mean, that's not really a gotcha. That's just what words mean and what things are.
Okay, yeah. So a dictionary term versus something that is sticking to something due to an outside force. I don't understand how,
Well, a dictionary is just gives you the meaning of the word, right?
Right. And this is how a spirit level works, okay? So that's what I'm trying to get at. You're saying because the definition of level is flat and water is perceived flat,
It's practically used as flat, but go on.
is perceived flat on this planet,
And measured.
therefore flat Earth. That's how you infer that.
Well,
No, this is why.
And then you say, welcome to flat Earth.
No.
I said the water's level. You said the water's level because of gravity. So I said, okay, so water's level because of gravity. And you said yes. And I said, okay, can you read the definition of what level means? Flat. So you're saying gravity makes the water flat. Now, you can think whatever you like about why the water's flat, but the water being flat and 70% of Earth's surface means obviously Earth is not a ball. So, I mean, that's just it, really.
So I said water seeks a level, right? It is free forming, right? It's a liquid.
You said water is leveled due to gravity, is what you said.
Water is on the ground and levels out. It seeks level. It seeks level. It doesn't have to be level. We see waves in the water, right? And you saying waves can't exist because water is flat. Therefore, the Earth is flat.
Exist. You just you understand what was being spoken about, and you said water is level, and you agreed level means flat. You're saying water seeks its level, which means flat. So the natural physics of water is flat. So 70% of the Earth being flat water can't be a ball.
You missed one point, okay? Because the water can only seek doesn't mean it is, correct?
So you're saying that water is seeking flat on a globe Earth, is your argument now?
I'm saying gravity and Earth is its container. Welcome to Globe Earth.
Dude, that is the dumbest thing I've heard today.
That is what it is.
You already agreed that it was flat, so come on. You can't welcome me to Globe Earth after you've just welcomed yourself.
I agree that it seeks a flat.
Well, guess what, Stick here? I know you're trying to unpaint yourself out of this corner, but the Suez Canal is 120 miles. No locks.
Why would water?
So it's not only SOT level; it's at level, at sea level.
Yeah. Why would water seek to be flat on a ball? That would make no sense anyway. And yes, level means flat. Sea level. What does sea level mean then?
The level of the sea.
So sea flat.
No, the level of the sea. The distance.
You read the dictionary earlier, and it said even flat for the definition of level. right?
All you can do now is lie, Stickiermoss.
Yeah,
No, I don't have to lie. I can take my time and think about my answer. I'm not a child.
I was giving you two chops.
It's like you guys are not talking on my points. You guys have not asked why I believe the globe.
That's all right. Take your time.
And you guys aren't asking any questions about why I know we are on a globe.
Okay.
And now you're calling me global.
So we're talking about sea level. Level means flat. So what does sea level mean? Sea flat. And you're taking your time to think about it. What's the response?
So either be honest or lie.
When you think about the water over the vast distance on this celestial object, it is not level, but it is seeking level.
So why is it called sea level?
What did you say? What did you just say?
So why is it called sea level if it's not level?
Because that's the altitude of the sea.
So it is level.
If you're saying level is flat.
That's what the dictionary said that you read earlier, remember?
So level's flat. Like I said, you can only be honest or lie. Which one are you going to do?
No. It's okay. So in perception of the person where they're at, it is seeking level. Water is always going to seek level. It's a free-flowing substance.
The term, right? Like it's called sea level. You read the definition of level earlier, which means flat. So sea flat.
Correct.
Right? So sea flat.
Right. But like you're not understanding where the water is, it is flat.
Okay. I agree. The water's flat.
So we both agree on that. We can move on.
Yeah,
where the water is, it's flat.
Well, snacks in the back, bathroom on the left.
It is perceived flat wherever it is.
That's awesome. Sorry, gentlemen, to interrupt. You can continue this conversation as soon as I've finished. As soon as I finish, you can continue. We've got a lot of no rolled people in the server, guys. If you want to go up to voice check-in number 1, I'll meet you right up there and give you voice verified if you pass muster. So there's about 2-3 people in there that haven't got any roles. If you want to go up to voice check-in, we'll have a quick conversation so you can come back down there and have the conversation. Sorry, guys, didn't mean to interrupt, but I wouldn't have got there if you'd have carried on talking.
Yeah, cue me in when you guys want to talk about satellite systems. I'll be here.
Excellent. So in the meantime, let's see where we've come so far. You said that gravity is what makes the water flat. So gravity is a proof of flat Earth, which we agree if we believe in gravity, right? If gravity is just up and down, which is perpendicular to level, right, which is flat, and horizontal, which is the second word in that definition. So now we have a horizontal, level, flat, expanse of water that takes up 70% of the known Earth's surface. So you have two options: either redefine words or measure the water and figure out whether it's one or the other. All right, I rest my case.
He's still thinking like he's outside of the system. He's talking about satellites. Bro, come back to the ground, to your immediate experience where you can observe, verify, demonstrate. Here, in the real East level.
Jimsy, are you seriously? If I can give you a way to test this, are you gonna follow through? Because I can tell you how to do it for like $200.
Test,
yeah, but you're gonna need friends in very south places, whatever that means.
Dude. Listen, friend. Keep in mind, yes, you have people here who may not want to hear it, but there's at least one person watching who might want to hear it. Why don't you tell them?
Okay. So all you need is someone in Chile, someone in Australia, right? Someone in South Africa, Cape Town, who knows, right? You can communicate to each other through these systems that fly from pole to pole to polar orbit, right? This is how we get communications down in Antarctica. It's a polar orbit. You can all communicate through one system with your own encryption, your own made encryption, right? You can download VPNs on top of that, and you can transmit and see your friends transmitting signals on different carriers and transponders on the system as it flies over Antarctica. You can see it from every direction as it hits that pole.
Awesome.
So that's how I would test it, and it wouldn't cost that much.
Awesome.
If you wanted to transmit, it would cost a little bit more. You're talking probably about $100 a minute.
Sorry, what's that got to do with measurement of the surface of the Earth?
So who was talking about triangulation? Was that you, FE Jedi? Were you talking about triangulation?
I was talking about celestial navigation.
Correct. So that's triangulation. That's you're locating where you are based on the time, right? And then how far you are away from the equator. And you're looking at a star and you're looking at the horizon, and you calculate all of that with simple trigonometry, and you can figure out where you are based on information of tracking these stars that move around the Earth in a very specific way. Like, what's the Southern Cross, man? How do you navigate south of the equator with the Southern Cross, right? How does that work?
It's done on it's just that simple.
Sorry, by measuring an elevation angle up to that star at a known time of year with your azimuth, your direction and time, right?
Right. Based on what?
So
what data?
I said angle. Game over.
Okay.
As soon as I said angle, that requires the surface of the Earth to be level, unless you're going to start drawing tangent lines.
Okay. What are you missing there? The azimuth, right? The azimuth is very important. Like the degrees you are on your compass is also very important in this. How does that work? What information are you going off to navigate with?
Compass, time, elevation angle to star.
Show me how that works. On a paper, have you done this before?
You use a flat plane.
You use a sextant, which is designed to be used. Yeah, you use a sextant designed to be used on a flat plane. Yeah, and a compass,
even
and a clock.
When you're getting your bearing and your azimuth and all of that stuff, like again, you're assuming that you're on a flat plane.
Show me how you can navigate with the Southern Cross.
Right now that what I said is true. If you're paying attention and having the same conversation that we're having.
Okay, I'll listen.
All right, how about you? Would you mind reading this for me, sir? I'll give you a little graphic to go with it as well.
I'm listening.
58 minutes past now. No, can you read it?
Read what?
Can you read it, please?
Sorry, you can take over from here, Jedi.
No, I'm not reading your information. Can you?
Why not?
Because you've read it before, right? Do you need me to interpret your data?
Did I? I mean, I just started talking, so I don't know these games we're playing.
Okay.
Anyway,
are you going to read something I give you?
I gave a citation. So what's this weird thing about?
Are you going to read something I give you? And I apologize. This is short. I thought you were going to send me to a site. My bad. Okay, that seems really. It may be a bit confusing for beginners to imagine the celestial equator in the related declination. A really simple way to picture this is to replace the sphere of the Earth with a flat circular platform on which the telescope stands. The platform has the size of the Earth's equator, and the axis is the polar axis. Even when moving the telescope to any place on the disk, the declination of the object will always be the same. The famous Andromeda galaxy M31 can, for example, always be found at deck 41 41 degrees 16 seconds. I don't know. This is independent if we observe it from New York, Los Angeles, or Munich. So declination, are you talking about magnetic declination?
Using a compass.
Right. So the magnetic declination, correct?
Yeah.
Okay, yes. That is always going to be a factor. And it does move. So explain why it moves and how that works with flat Earth.
Shit, mate. It just moves, right?
Got
you
it.
know it moves. I can't explain it to you. I ain't God.
I
right?
can't either, man. Like he threw this at me. I thought Elijah had more information.
Elijah's point was really good. Maybe you should read it again.
Yeah, it talks about declination like 4 or 5 times in that paragraph. And why does it move?
It's just easier for you to put yourself in a flat circle, right?
It's easier just to go and be with the sheep, right? You know?
Well, it's just easier to use this device on a flat, horizontal circle of equal altitude.
Whatever is easier.
Well, yeah, but that's what's required, right? Because it is much easier to measure an angle off a straight horizontal baseline or use this device on a straight horizontal baseline than a curved surface. That's why we do it this way. So for all intents and purposes, the Earth is required to be flat to use a sextant and this device.
No, it's a perceived bottom. You're shooting an inclination, man. That's what you're shooting. All right? It's going to always be straight. You're using a straight shot device. Just like this telescope on the ball. Do you see that line coming out of the telescope to the star? Okay, that's one angle, right? You're going to look at the tip of the ball that you can see. That's the other angle, and there's 90 degrees off of that, and that's how you get it. Do you see? You perceive a line. You look straight at the edge.
I get it. My God, you don't have to repeat yourself, dude. I get it. I understand what you're saying, but you said 90 degrees on the horizon. You know the 90 degrees. Hold on. You understand the ground position of the star is beyond the horizon, right?
Say that. I'm sorry, I missed it. I was too much thinking about what I was going to say next. I apologize.
That's fine, no problem. You understand that the GP of the star is beyond the horizon, right? It's not on the horizon, it's beyond the horizon. In actual fact, it could be in front of the horizon, right? It could be at 89 degrees above your bloody head, so in front of the horizon. Or it could be at 32 degrees and beyond the horizon. What's the ground position angle of that star? You said 90 degrees, right? Yes?
Hold on, doing 2 things at once. So no,
well, maybe just
so at a right angle, this is how this is the perceived angle, right? On a right angle, that angle is 90 degrees. That's what I was talking about. If you misunderstood what I said, that's fine.
No, that's fine. So the ground position of the star has 90 degrees, yes? 90 degrees above your bloody head, so in front of the horizon. Or it could be at 32 degrees and beyond the horizon. What's the ground position angle of that star? You said 90 degrees, right? Yes?
Hold on, doing 2 things at once. So no,
well, maybe just
so at a right angle, this is how this is the perceived angle, right? On a right angle, that angle is 90 degrees. That's what I was talking about. If you misunderstood what I said, that's fine.
No, that's fine. So the ground position of the star has 90 degrees, yes?
Yeah.
Awesome. And we can have the ground position of the star in excess of the horizon up to about 3,000 miles in the case of Polaris, right?
I don't know.
Okay, so this is how we got your latitude lines, but I'll go slowly for you. The ground position of the star is beyond the horizon. It's the ground position on the surface of the Earth. So we can have stars that are low on the horizon. Their ground position is beyond the horizon, up to a distance of 3,000 miles. The ground position of that star is 90 degrees. That's a 3,000 mile distance between that 90 degrees and you with your sextant that I'm going to put on the floor. So that's 3,000 miles of a flat horizontal baseline between you, sextant on the floor, and the GP of the star. Not just that star.
I get that, though.
Hold on. I haven't finished my point. Every single star in the sky has got a ground position of 90 degrees to you, not just you, everyone who's using the sextant at the same time. Let's all sing Kumbaya, hallelujah. We can all do this together. So every single person on the face of the earth has got a sextant and a 90-degree ground position to every single star. How the hell do you get that on a curved surface, mate? You can't have 90 degrees on a curved surface, let alone thousands.
Do you know what the Leo constellations are?
Yeah. Do you understand what I just said?
Yes.
Let's talk about what
you
I
explained.
Just said.
You explained a little bit about how a sextant works, and then you said you could get a bunch of people to do it, and you can see all the stars. All the people see all the stars.
You're an idiot. That's not what I said. I'll say it again just so we're clear. Every single star has a ground position on the surface of the Earth, which is 90 degrees. How many stars are in the sky? Let's just say 1,000. And then we can all, everybody on the face of the Earth, get out our sextants if we've got them, and we can measure elevation angles to every single star. So, lots of people on the surface of the Earth have got ground positions of horizontal baselines to stars. That requires the surface of the Earth. My God, doesn't even require. It's obvious that the surface of the Earth is level and flat to do this type of work, right? 190-degree ground position on a star on a curved surface, fucking impossible. I've given you 1,000, and everybody at the same time using sextants to measure angles to all stars.
Negative. Do it.
Negative.
Do it for the Southern Cross. Explain to me how that works. Why is everyone pointing south? You say declination 3 times in a paragraph. I guess that proves it.
No, I'll say ground position. I'll say ground position of the stars, and then just leave it
At
there.
what point is it directly above your head? Right. That's the ground position of a star.
No,
just say it simply.
Yeah, not directly above my head. That's the zenith angle.
No, that's which is the ground position of the star.
Exactly.
That is the ground position of the star.
Yeah. So all stars have got a ground position, haven't they?
Correct.
So all stars have got a ground position of 90 degrees, yes?
No, it would be 180 if it was directly above you. 90 is the horizon.
Right, idiot. You don't know what you're talking about.
Yikes.
Sorry.
Okay.
Can I say something real quick?
Good point.
Yeah,
so when you guys were talking about declination, you said magnetic declination, and
I thought that's what he was talking about.
So that's not it, because declination is exactly the same as the degrees of latitude, and will always be shown with.
Elijah should explain that. He posted it. He should have explained it. But Diesel Boy,
I'm telling you that you were talking about magnetic declination, which is not the same as the declination we're talking about in celestial navigation.
What does declination mean?
I just told you it is when. Okay, so in a nautical almanac, you've heard of that, right?
That is. I think you're going off on a different route here.
No, I'm not, because I'm just making sure that you understand the correct definition of declination in the conversation here, because it matters. And you're thinking of magnetic declination.
Let's go back 30 minutes. Let's have you explain to me.
I don't want to hijack the conversation. I just wanted to make sure that you understood that.
I apologize.
That's
go
not
ahead.
Same. Because it matters in this discussion.
Right. Go ahead.
What declination means, right?
Yes. Go ahead.
Yeah. So I'm referencing a sextant user's guide. And Chris, I don't want to hijack your conversation or anything.
Take it. No, take it away, please.
Okay. So this book is published. I'm not an expert in this, okay, but the Nautical Almanac is published every year from the U.S. or British government. But anyways, in this book, it shows use it when you use celestial navigation, and it has your Greenwich hour angle numbers in here. Okay, so remember that the nautical almanac is showing you the position of the sun over the Earth. It is showing you the location of the base of a pole that is stretching up to the sun. I know you guys already went over this. Greenwich hour angle, GHA, is the latitude of the sun. It shows the degrees west of Greenwich, England. And then declination is the longitude of the sun, and it shows the degrees north or south of the equator. Now, does that make a little bit more sense? Because I feel like I don't know. I just
right. So if the illustration was better underneath it, so for all of you guys who aren't getting that, the new Greenwich is actually the zero azimuth, and it goes around the entire spherical globe, and that's my perception of that.
But we moved past the spherical globe already. We all agree that water's flat.
I'm sorry, Heretic. I didn't get any of that. It's all just, you're very, very loud to the point I couldn't get any of that.
Okay. Take two. Never mind. Got a phone call.
The angular north or south of the celestial equator. The arc of an hour circle between the celestial equator and the point on the celestial sphere is measured northward or southward. It has nothing to do with magnetism. So get magnetism out of your head in regards to declination in celestial navigation.
Okay, let's
Simple.
get
Google
south
it.
figured out then.
That's what I wanted to say right there.
Yeah, let's get south figured out. If we're going to talk about magnetic, let's talk about south.
The southern south has nothing to do with whether or not the surface of the Earth is flat or not. You can't use the stars, which are referred to as a celestial sphere, in regards to the surface of the Earth. So your Southern Cross reference is bunk in this case. Let it go.
I didn't catch why.
What does the Southern Cross have to do with the surface of the Earth or its shape?
We navigate with it.
It's mutually exclusive. It's just stupid. And what does that have to do with the surface of the Earth? Would you take an angle to the celestial? Would you take an angle to that celestial object to navigate with it?
Sorry, say that again.
Angle.
Would you take an angle to the Southern Cross to navigate using that particular constellation? Yes or no?
If I was south of the equator and could see it, yes.
Or south or north, would you use it and take an angle to get your location and navigate with it?
Would I use the
take an angle to it? That's how celestial navigation works. What is an elevation angle?
It's your distance of look from your feet upward.
It's an angle. It's in the name. What is an elevation angle? You need a flat baseline. Welcome to Flat Earth.
It is the distance between directly beneath you in degrees going upwards.
90, that's a zenith. I'm asking about elevation angles. Would you take an angle to the Southern Cross, depending on your location, to navigate, yes or no?
Angle, mate.
Yes,
God.
You do elevation angles.
Yes, you would. Thank you very much. Welcome to Flat Earth.
Okay.
You just debunked the globe. I appreciate it. Thank you.
Are you talking about altitude, or are you confused on how elevation works? Because 90 degrees is straight in front of you, right?
Confused. No one said altitude. I said elevation angle. Who said
I
altitude?
think you're confused. I can't understand you where you're getting at.
Sticky, you're the one that's confused.
Okay, what did he say and how did that make sense? What did he say that is in revolving flat Earth? What did he say that proved it? Because I missed that entirely. Does someone have a better
elevation angle to the Southern Cross to navigate?
I think it goes back to what Jetta was telling you about.
It's a very simple question.
Getting the GPS of the stars, right? So if you're using angles, and this is what the other gentleman is saying, and I think maybe his phone is a bit muffled, and that's why you can't hear him that well.
Yeah.
But if you're using angles, and like you just said, 90 degrees is straight out in front of you. But the GP of that star that you're using to get your measurement, that GP could very well be, and often is, beyond the horizon. So beyond any potential geometric Earth curve.
Right.
And so you're navigating using a flat baseline on a flat Earth.
So if you look up how to use a sextant, there's always going to be degrees of error, and this is based on your perception of the horizon. Okay, and if we want to talk about that, then we have to talk about the trigonometry that is light perception, which I have zero understanding about how refraction works. So I'll mute my mic right now. You want to talk about refraction?
Oh, thank God.
No.
Hey, one thing, I don't know if this was like said specifically, but when you're using celestial navigation, you are assumed to be on the equatorial plane, which is the center of the sphere, the center of the flat sphere, the flat sphere, the center of the middle of the ball, right? But in reality, that's the flat Earth.
I'll agree with you guys that it's perceived flat.
No, it's required to be flat because we've said the word angle about 50 times in the last 5 minutes.
I saw
every time you say angle.
Measured flat.
Now let me know. I saw and let me know if you guys would ever do this. But I saw a picture online, and this guy had a spirit level which had eyelids cut out of it, basically windows in between. And he leveled it up with the horizon and saw that there was nanometers of curvature on the edges of the horizon.
Oh, you're a tiny earther?
Would you guys ever do that?
Are you a tiny earther?
Would you guys ever get? All you need to do is buy
the
like
circle Stickiermoss.
What's up?
Can you?
I didn't do this test.
No, I'm asking you. You brought it up. Can you complete the circle?
What do you mean? I've flown around the Earth.
Okay, listen. If you said you saw the curve on the edge, if you complete that circle, would or would not that be a tiny Earth?
Oh no, dude! It's so fucking huge. It was nanometers in differential.
Yeah, okay, but if you're standing at the beach and you see the curve left or right, if you complete that circle,
you can't do it with your naked eye, dude. We're talking nanometers.
Well, what are you talking about?
We're talking about setting up a precision level.
About practice? Okay, well, guess what?
Well, I got halfway through explaining.
Hey, buddy, I know you like to do the whole perceived flat thing. Well, I tried to bring it up to you, and you seem to ignore it. The Suez Canal, 120 miles, no locks. Would you say that's perceived to be flat, or is it just flat?
Do you want me to show you
just
a
answer
picture
the question.
of? No. Wait. I'm about to.
You weren't following my. You weren't following my question. So
yeah, okay,
we'll
it's because it's perceived that way. Go ahead.
What's perceived that way?
The flatness
of the Suez Canal.
Correct.
Well, riddle me this then, please. Both ports at either end are at sea level. There are no locks.
Yeah, and that's an elevation.
So if it's a hump of water, what's going on there?
Okay.
At what point does the water
I'm on top of a mountain, right?
No, we're talking about
water down
Canal.
there.
We're talking about the Suez Canal.
Right. Okay. So let me go back to this then, because we kind of
you're going to go back to bullshitting. Got it.
No, dude. We talked about this. We talked about this prior. Okay. It's perceived flat where you are.
No, it's used flat. It's 120 miles.
Okay. There's people standing upside down in Australia. Okay. Does that make sense to you?
What did you say?
People who are standing upside down in Australia right now.
That's what you've been duped to believe. Yes, I get that.
Okay.
Go on.
So there's your answer.
Wait. You're saying that's a fact?
It is a fact.
Well, wouldn't we have to have the Earth's surface curving for people to be standing
based on your reference, man. Wherever you are, it's based on your reference.
Oh, the Suez Canal we're talking about, though.
No, now I'm kind of like dipping into
You're
like
lost, aren't you?
space time. Yeah, no, space time with reference frames. Do you know what that is?
You don't
What's
just
that?
get to make
It's more
claims,
math
bro.
that you guys just throw away.
Well, weren't you the one chanting "mass attracts mass"?
Yeah.
Yeah.
Okay.
Did you know that that's a part of it?
Did you know if you've got no
You're so funny, man. Did you know that that's a part of it? Einstein only
really?
extended upon the idea. Really?
Oh, really? So,
Really?
So when's the next time I should expect to see objects being dragged towards one another?
How about you use your triangulation on those
When's the
stars we're
next
talking
time I
about
should
and
expect to
explain?
see objects being dragged towards one another?
Right.
Yeah,
'Cause
when
that's how
should
that
I
works.
see that?
Because that's how that works.
All right,
Oh,
guys,
what?
we've got about 5 subjects up in the air right about now. It's
I'll stop being
kind of hard
snippy
to
if
follow
he
any
does.
one of them.
Oh, the debate's over,
that's
pal.
fine, no worries.
Right.
Yeah.
So I'm done. You're right.
Well, you said angle. It ended at angle.
90.
You can't have an angle on top of a
As soon
ball,
as-
right?
You can't have
Incorrect.
any
You
angle.
You can have any
You
angle
can't
that
have any
you create. You create the angle in triangulation.
What
You
the
create
hell?
the
Your bastardized perception. huh?
You do though, because you have to look at something, right?
Yeah.
That's you
Yeah.
creating that angle.
Yep. You are creating a triangle between 3 points. Sorry, sheepdog. You are creating a triangle between 3 points. I'll keep it simple for you. Let's put the sextant on the floor, and whoever's got background, can you mute your microphone, please? Thank you. So you create a triangle between you, putting the sextant on the floor, the star, which is above the horizon in the distance, and the bit that you failed to remember from earlier, straight vertical line down from that star to the surface of the Earth, which is a GP, ground position of that star. Celestial navigation works on the premise of a 90-degree right-angle triangle, and the right angle is under the star. The GP angle is 90 degrees. So you've made your triangle. Now, as we pointed out earlier, the GP can be well in excess of the horizon, 3,000 miles in some cases, according to, observations of Polaris. So that's a 3,000 horizontal baseline, 3,000 mile flat horizontal baseline between the GP of the star and you, if your sextant on the floor. Not just one star. Every single fucking star in the sky has got a GP of 90 degrees to you with your sextant on the floor. The reason why I put the sextant on the floor is because there's usually some kind of correction that you've got to do. A dip correction to the horizon, for example, you brought up refraction, or an altitude correction because you want to correct your altitude down to 0 feet above the surface of the Earth, so you're on the surface. Between the sextant that we've put on the surface of the Earth and 3,000 miles away is a 90-degree ground position of one star. Celestial navigation works on the premise of a 90-degree triangle, and it requires the Earth to be flat. Sorry, mate, it just does.
But it also requires time, and you can use the Southern Cross. And the Southern Cross, viewable, what parameters are you using to find where the star is? What parameters are you referencing your location with? You talk about these GPs, right? Right?
Yeah.
These GPs.
Yeah.
How do those GPs work? Are you using global data or are you using flat Earth data?
Well, we will always
how
be
does that
using
work
flat
in
Earth
flat
data.
Earth?
Hold on.
How does that data work in flat Earth?
You asked me a question. Dude, shut the fuck up and listen. You're going to be using flat Earth data because, no worries. You're going to be using You're going to be losing flat Earth data because that's where you got your longitude and latitude lines. Declination angles to Polaris is where we got our latitude lines from. You can stick your latitude lines around a ball after you've measured an angle, which requires the Earth to be a flat horizontal baseline. You can do whatever you like after you take your measurement from a flat Earth, mate. But you require the Earth to be flat to bastardize it and turn it into a ball if you want to. But you said angle. That's the Earth being flat, mate. Game over. Sorry.
I did say angle. There's a 90-degree angle, and then there's your perceived line to your target. That's it.
Yep,
if you do anything wrong, it doesn't work. And then you talk about where are you finding the data?
The data?
Yes, you need to reference where the star is and the GP based on a globe Earth.
No.
Well, show to me that it's not.
Because do you not understand? Do you understand what I said to you about where you got your latitude lines from? Latitude lines come from declination angles to Polaris. 90 degrees, zenith above your head. There's Polaris, you're at the North Pole. Brr, isn't it cold? Go south for a few thousand miles, turn around, take a look at fucking Polaris. It's descended by 45 degrees. What's my latitude?
That's
45 degrees. Yeah, I know it's true. And every single time I keep seeing angle, that's the Earth being flat. Because you're not going to be measuring angles on curved surfaces now with angle measuring devices that are required for the surface to be level. Now, are you? I don't understand how this is hard for you. Oh, yes, I do. You believe the Earth is a ball. You want to die on that fucking
You're looking at a target.
Yeah, and that target's got
your location to a target.
Yep.
That is what you're doing. Why would that be curved? Tell me why you would curve your sight.
Dude, I'm talking about the line between you and the GP of the star, which is on the surface of the Earth, not the elevation angle up to the star, you fucking idiot. Have you not followed the conversation I've been having you for the last 10 minutes?
Absolutely
GP,
not.
Geographical.
Get more angry.
Geographical. Yeah, geographical position, because you haven't been listening.
I don't see why you're using globe Earth GP locations for a flat concept.
Not because, again, you didn't listen to what I was saying. Your latitude lines come. Yeah, GP.
Global position. What does that? What does that mean?
Oh my God! My God! Right, shush.
Right? What's a GP?
Position.
I'm sorry, I'm wrong. What's a GP?
Geographical position.
You seem surprised that you were wrong, Stickiermoss.
I am actually, dude. I kind of went on a fucking.
Yeah, what a joke.
I'm sorry. I actually am on Google right now.
It's funny. I appreciate it, dude. Don't apologize. It's brilliant.
Hey, look, guys, we can always move on from Stickiermoss. He doesn't understand what a GP of a fucking star is.
Yeah, dude.
Totally clueless.
You guys got me beat. I'll give you that. This is your server. I appreciate having me.
Reality wins, pal.
Sure.
Did you realize it's just literally?
I'm agreeing with you, but not because I agree with you.
No one cares.
It's another level, dog. See you next time.
No one cares, dude. You're talking nonsense.
It's a level called doublespeak.
He read my message and realized people are listening to him, so he got off of here.
What is your profession?
See, old friend, I brought more soldiers than you did.